So we're gonna construct methane with the molecular model. So for methane, I'm gonna need 4 hydrogens, so 4 yellow, and 1 carbon, a black. And then I'm gonna put 4 bonds on my carbon. Just like that. Then I'm gonna add my hydrogens. Just like that. So there's methane. Using a protractor, I'm gonna measure the bond angle between this bond here. So you should pretty much already know what the bond angle is going to be for this, but on the retractor it shows about 107 degrees. So now replace the second hydrogen with another chlorine sphere. Replace the hydrogen of the methane molecule with the colored sphere. So I'm going to put one of my colored spheres, just like that. The new model is chloromethane, methylene chloride, CH3. So here's our CH3 and then Cl. Grasp the atom representing chlorine and tilt to the right. Keeping 2 hydrogens on the desk, write the structure of the projection on the report sheet. So now I'm going to replace the second hydrogen with another chlorine sphere. Like that. So now we've got 2 chlorines, 2 hydrogens, and a carbon in the middle. So I'm going to grasp the chlorine, tilt it to the right. So here we've got, depending on how you tilt it, you'll have the different structures in the book. So something like this, or something like this, or like this. Construct the molecule ethane, C2H6. So now we're gonna remove the chlorine, and then we're going to add another carbon, and we're going to remove the other chlorine, and then we're going to add hydrogens all around the carbon. Just like that. And there we've got methane. Ethane, sorry. So write the structural formula. Are all the hydrogens attached to the carbon atoms equivalent? So you note that there is a plane of symmetry here between both sides. Oops. Or like this. Draw the sawhorse representation of ethane. Replace any hydrogens in your model with chlorine. So we're going to remove this one. And we're going to place the chlorine on top here. In your molecule of chloroethane, if you choose to remove another hydrogen, note that you now have a choice among the hydrogens. You can either remove a hydrogen from the carbon to which of the chlorine is attached, or you can remove a hydrogen from the carbon that has only hydrogen attached. So basically, if you add another chlorine, you can put one on this carbon, so here, or you can put one on opposite side, opposite carbon, so here, or here. So I'm going to go ahead and put it on this side here. So each carbon will have a chlorine on it. And you're going to want to write the structure of this. So chlorine, carbon, carbon, chlorine, and hydrogens on the other ends. Compare the structure to the model that would result from removal of hydrogen from another carbon. Okay, so now we're going to do the other way around. We're going to place this here. Just like that. So now we've got two chlorines on one carbon, and the other carbon is just has hydrogens attached. So this would be 1,1-dichloro, because there's two, methane, dichloroethane, because there's two carbon atoms. So 1,1-dichloroethane. And then, like we had it before, if the chlorine was here instead, that would be 1,2-dichloroethane. So now we're going to go ahead. Butane has a formula of C4H10. With the help from a partner, construct a model of butane by connecting 4 carbons in a series and then adding the needed hydrogens. So we're going to remove these, and we're going to place this instead of destroying the one we've already made. And we're going to use this as our end carbons, or starting. So we're going to need another bond. We're going to put that there. There. Since it's only CH3, it doesn't really matter where we put our carbons, since it's hydrated or saturated with hydrogen. 1, 2, 3, 4. So here is my butane. Oh, I'm missing a hydrogen. Give me a second here. There we are. It fell off. Just like that. So first, orient the model in such a way that the carbons appear as straight line. So here's the straight line. And then here's the zigzag line. Then twist the, oh, I'm missing the hydrogen, sorry. There we go. So straight line, zigzag line, then twist around the CC bond so that a part of the chain is at an angle to the remainder. So something like that. Draw each of the structures in the space on the report sheet. Note the structures you draw for the same molecule but represent a different orientation and projection. Cite along the carbon-carbon bond of C2 and C3. So this would be C2, C3 on the butane chain. Draw a staggered Newman projection. Rotate the C2 carbon clockwise by 60 degrees. So
Alright, so 6 moles of HCl. So for every milliliter, we're going to add
60 degrees.
1 drop.
Draw the eclipse Newman projection. Again, rotate the C2 carbon clockwise by 60 degrees. So this would be like 120. Like that. Okay. Increments. So continue to do it 60 degrees. About there. And about there. Well, about there. Examine the structures of butane for equivalent hydrogens in the space in the report sheet. Redraw the structure of butane and label the hydrogens that are equivalent to each other. On the basis of this examination, predict how many monochlorobutane isomers could be obtained from the structure you drew in C6. Test your prediction by replacement of hydrogens by chlorine on the model. Draw the structure of these isomers. So you could put a chlorine here, 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 anywhere where there's hydrogen. So I'll just go and show you guys a couple of examples. So you could put a chlorine there, just like that. You could put the chlorine here, and essentially that would be the same thing, because no matter where it is on this molecule or this molecule, it's these carbons are not chiral, so it doesn't matter like where it is, it's still the same molecule. Reconstruct the butane. First form a 3-carbon chain. So here's our 3-carbon chain. Then connect the 4th carbon to the center carbon of the 3-carbon chain. Okay. So here we're gonna make this instead. Something like that. Like this, and then like this. Let me switch this bond out to the bigger one. So we're gonna put that here. Put this here. And we need an extra hydrogen. And there we go. Okay, add the necessary hydrogens, draw the structure of 2-methyl-propane. So 1, 2, 3, there's your propane. 1, 2, here's your methyl group. And every single carbon has, 3 carbons have 3 hydrogens, and 1 carbon, the center carbon, only has 1 hydrogen to make its 4 bonds. Can you manipulate it and twist it around? Yes, but a lot less than we had it a while ago, as in butane. So since propane, we can twist it a little less. We can really only rotate the hydrogens around. We can't rotate the carbons. Alright, examine the structure of 2-methylpropane for equivalent hydrogens in the space of the report sheet. Draw the structure of 2-methylpropane and label the equivalent hydrogens. Predict how many monochloroisomers of 2-methylpropane hydrogens by chlorine on the molecule. So again, as I said before, this, and this are all the same. So if you put like chlorine here, it would be the same as putting it on this one or this one. But if you put chlorine here, then it would only belong here. There's no way to orient it where it would be the same thing. So it's only on this one, in the center. Okay. There are 2 isomers for the molecular formula C2H2O. So C2, so now we only need 2 carbons. And then we only need 2 hydrogens. So here's our C2H6. And then if we want to add oxygen in it to make an alcohol, so we're going to take a hydrogen off, we're going to put our oxygen on top, and then we're going to make an alcohol by adding a hydrogen on the oxygen, just like that. So that makes our 2, that makes C2H6O, or ethyl alcohol and dimethyl ether. With your partner, construct both of these isomers, draw these isomers, and report it. So you can either put it on this carbon, or you can put it on this carbon. There's only 2 ways to do this, so now it's on a different carbon. You can, just like that, you can have it like this, it really doesn't matter. Manipulate each model can either be turned into the other by simple twist and turn. So just like this, where you have 4 hydrogens on one side, and here you have the oxygen and the hydrogen, or you can twist it like this, where you have still 4 hydrogens on one side, but you also have an oxygen and 2 on the top. So we're going to use these little springs for butene so that we can make the double bond. Just like that. And then we're going to need another hydrogen, carbon, like that. Then we're going to take off this oxygen group, and we're gonna place a hydrogen like this. So, oh, missing a hydrogen. So this would be less saturated than our other butane, something like this. Or you could have it where these two hydrogens are cis to each other, or trans to each other, sorry. So you just kind of flip it around. Like this. Just like that. And then we can do the butene or tine. So we're gonna need another double. Flexible bond. I'm gonna break this and I'm gonna break that real quick. Just gonna do this. So triple bonds, as you've probably seen in pictures on a Lewis dot structure, these are going to turn out to come straight. There's not going to be any angle between carbon-carbon bonds. So there's your triple bond. And that should give you enough information to finish the lab report.